Okay, so we're going to talk about the law of sine in a special situation called the ambiguous case. So the first thing I'm going to do is I'm going to write down what we know. So AB is 20. So these two triangles have the same letters. AB is 20. So that blue line is 20. And AC is 17. So that has a length of 17. And we've got the angle ABC is 50. Okay, so this angle right there is 50 degrees. And this one right there is 50 degrees. Right there. So notice we have angle side side, angle side side, and these are not, I mean, they clearly don't look the same, but they have congruent angles and two congruent sides. So when you have angle side side, this is an example that you don't have congruent triangles. But let's try to solve for the size of angle C. Okay, so we want to find this angle. Let's call it theta. Okay, and we want to find this angle here, and I'm going to call it alpha. Okay, because I'm going to call angle ABC. We want to solve for angle alpha. But first, let's solve for this one here. So, setting up the sine rule, I know that I'm going to have 17 over angle 50, or sorry, over sine 50 equals 20 over sine theta. Okay, and so if I cross multiply, I end up with 17 sine theta equals 20 sine 50. Okay, so let's find out 20 sine 50. Okay, let's make sure I'm in degree mode. Second mode gets me to check that out. You should always check that out. Okay, second mode to quit, get out of here. So we want to do 20 sine 50, enter, and that gets me 15.32. So I'm going to write that down. 15.32, and so I've got 17 sine theta equals 15.32, and then I'm going to divide both sides by 17 in order to make this cancel out. And then I get sine theta equals, okay, so 15.32 divided by 17, and I get 0.9012. Okay, and some students were getting to this step and they said, oh, the angle's small. Like, no. To find the angle, we have to hit second sine. So we're going to do, we need to find the inverse. So we have to hit second sine, 0.9012. And that gets us theta. Okay, so what does that mean? Okay, so if I push the second button, and then I hit sine, then it gets me this here, and then I'm going to put in the decimal, but I can just do second there to get the previous answer. I hit enter, and now I know that angle is 64.32 degrees. Okay, so theta equals 64 point, what did we say? 64.3 degrees. Okay, that's this here, 64.3 degrees. Okay, well clearly this one here is not 64.3 degrees, but we do know it's obtuse. So I'm going to take another piece of paper here. Okay. Now we know this is the same length as this, right? So something I'm going to show you, if I draw a dotted line here, and this is what we did on the Desmos activity here. Okay. We also know that that's the same length as this, right? And we know that this angle here is the same as this angle here. Okay, so if I'm going to use my compass here to show that the distance from point A to point C, I've measured it with my compass. And so if I go here, and if I swing it around, then where it touches that dotted line, I know that from A to here, that should give me a line with the same length. Okay, so I wasn't too careful with this, but anyways, this line should be about the same length as this one here. So given this information, so by extending this line here, if this is the same as length as this, we've got an isosceles triangle. So we know that if this angle here, what did we say before? It was 64.3. So if this angle here is 64.3, it should make sense that this angle here is also 64.3. Because if I have an isosceles triangle, if that side is the same length as that, then this angle is supposed to be the same length as that angle. So if that's 64.3, then this is 64.3. And then this here has to be 64.3. So now the other thing we know is if I've got a line, and if we know this is 64.3, I can find we can use we know that this could be a linear pair, so to find this one here out, I can do 180 minus 64.3, and then I end up with, let's do that. If I have 180 minus 64.3, I end up with 115.7. So this angle right here is going to be, that angle right there is going to be, let's just going to be 115.7. And so that is the angle of angle C right there for triangle 2. So go back to okay. You could hit pause and rewind to double check your work. So now that we know that this angle is 115, because those two make a linear pair, so now I can find the area of triangle 1. Okay, so this is triangle 1. So we know this is 50. We know that's 64.3, so we need this angle here. So what do? We can say 50 plus 64.3, and we get 114.3, and then I do 180 minus 114.3, and then we get 65.7. Okay, so this angle right here is 65.7. Now we needed that angle to find the area, because to find the area of a triangle, we need the included angle. So we know this is 20, we know this is 17, and our included angle we know is 65.7 degrees. Okay. The included angle by definition is the angle between the sides that we know the length of. Okay. So the area formula is 1/2 side sine, I'm just going to put theta, and we just said this is the included angle. So many students just write any old angle, which makes no sense. You have to have the one in between the ones that we have the length of, the 20 and the 17. Okay. So now I can go ahead and solve it. So 1/2 20 times 17 times sine 65.7. So let's do that. Okay, clear. 0.5 times 20 times 17 sine 65.7. Okay. Enter. And I know the area equals 154.9. What are the units? Centimeters squared. Okay. And that is correct. So if I'm going to write this in 3 significant figures, you should write your answer as 155 centimeters squared. Okay. And the other answer we said was 115.7, so I would write that as 156 degrees. Okay. I hope that helped.